Good morning. I am doing a short video on the air pressure map reading assignment from Chapter 8. As I've gotten I get a few questions here and there, and I wanted to make sure people were up to speed on what you would need to know to answer these questions correctly. I posted 3 videos here, and I've talked about them in a prior class, and I really found that you really needed this one as well, especially on the back half of the question. So I'm going to refer to these videos as I open up the assignment. I want to make sure you're understanding my clear expectations of how I like videos or how I like assignments submitted here and what I'm expecting from this assignment. So if you download the assignment, it would be great if you downloaded it and if you just re-uploaded it as a .doc file. It makes it a lot easier to grade. So if you download it, now I'm just going to open it. And I think it opened up right here real easy for me. And if I was going to go over, and I already did this once before, if you were going to look and complete questions 1, 2, and 3, they are all about comparing and understanding how the air pressure changes as you move up in altitude. And if you compare Lincoln, Illinois to Corpus Christi, Texas in November, you are going to find that obviously Corpus Christi is much warmer than Central Illinois. And this is going to lead, when you compare, and you have to find the 500 millibar, and this would be the surface reading would be the lowest one. So when I ask for the surface reading, that's the lowest one. That's the elevation of the city before the balloon is launched. So on the ground, the very first reading, and it says 178 meters, and the surface reading was 1,010. If I ask for the 500 millibar, the reason why I would ask for the 500 millibar reading, this is basically the altitude where we see a lot of the steering winds that direct our weather over the United States and Europe and the westerlies. Also about half of sea level pressure. And it shows you, and that is the altitude of the 500 millibar. As these numbers in air pressure are getting lower, you're going up in altitude. And what I'm doing is I'm having you comparing and contrasting Illinois and the Midwest versus Corpus Christi in southern Texas, and you will find out that the air pressure at different altitudes, the air pressure is different, and that's what creates the pressure differences. And this is what tells you how the density of air in Texas is different than the density and air pressure of the air in Illinois, because in one area the air is compressing and sinking, and in another area the air is rising and expanding. So I kind of walk through questions 1, 2, and 3 by filling in the altitudes here. You're basically understanding how the pressure gradient is created and how air is rising and expanding in one area and sinking and compressing in the other, because they're very different temperatures. And that answers questions 1 through 3. Question 4 has you looking at, again, the surface versus the 500 millibar and 300 millibar reading. And you're looking in particular at the direction column. So when you're at the surface in Corpus Christi, that wind direction is 45 degrees. You would put 45 degrees on this chart here, and if you zoom in, that will tell you the direction that the wind is coming from. And that's why if you were doing the surface wind at Lincoln or at Corpus Christi, you have a northeasterly wind. What you should be observing is that depending upon what level of the atmosphere you're at, the wind directions do begin to shift. And it depends on whether you're in the westerlies in Lincoln versus Corpus Christi, Texas. You could very well see a shift in wind directions that kind of indicate you're in different wind belts. So that kind of takes you through question 4. Question 5 is directly related to your understanding of surface winds and you labeling the winds around high and low pressure systems over the United States. You did this assignment in the previous exercise, and it wasn't done very well, by my opinion. And I would strongly advise you to watch, this video right here on the very first one really walks you through how to read how air moves vertically with highs and lows, okay? But then it gives you how the winds are moving around a low at the surface in terms of air movements around isobars. This diagram right here directly shows you how air moves 360 degrees around a low. So you use this diagram and it will show you, or this video, and it will really walk you through how to understand how airs move around highs in the northern hemisphere and how they get pulled into lows. And so your arrow should follow very closely the video's diagrams here, labeling winds around highs and lows off this diagram from the video. So this is a really good video to answer that question. Now I'm going to get back in here and show you, and that was question 5. So once you have these winds labeled, and you have 3 different wind belts or pressure belts that you need to label. There's 2 in the southwest that are highs and 1 in the northeast over Canada that are lows. This should give you on this day how the general orientation of the air. Now remember, the air will not be running in straight lines because of the Coriolis force pressure gradient, that if it was just a pressure gradient, you would draw straight arrows. The arrows end up rotating around the highs and around the lows because of the Earth's rotation, and you should have all picked this up by now by some of the lecture videos and whatnot. So question 6, it says, understanding how highs and lows are moving, if you were in central Illinois, based on we're in the middle of the lows over Canada and the highs to the southwest, what would be the general wind direction and air coming from? Okay? So describe the air motions over Oklahoma. And so since these are highs, obviously, you would look on your diagram, the video I just showed you, and really describe, what is the air doing vertically and on the ground? Is the air rising and is it converging and rising, or is it sinking and diverging? So you should be able to answer that on this date. What's the overall air movement around these highs over the Rockies? For question 8, you move over into here, and the very first question is you're reading weather maps, which are called the 500 millibar weather map. These are the way the winds are moving in the upper atmosphere. These are winds that are moving anywhere from 13 to 18,000 feet above the earth, and these are the winds that steer our weather. These slides show you the direction that the wind is pointing from, or pointing to come from. So all these winds, if you look at these flags, their flags are all pointing as if they're coming out of the west, which means the air is moving straight to the east. And that's why the weather in Illinois is typically shaped by what we see happening in Nebraska and Oklahoma. And we're not so much interested in the weather in Indiana because it's already passed. Now, to understand these charts, you have to understand all of the air pressure readings on here are 500 millibar. What changes is the altitude. These numbers to the top right indicate the altitude, or these lines are constant pressure lines, and they tell you the altitude of the 500 millibar height. And if you look at the ones over the southern areas, they're about 5,800 meters. And if you look to over Canada and the northern United States, they're about 5,400 meters. These lines are about 400 to 500 meters higher than these lines over Canada. This means if you were to look at this 3-dimensionally, these lines are tilted higher and they're drifting and sloping downward. So if you were on a slide, you would be sliding this way, okay? So you have to answer some basic questions. And if you look on this date, this was the way the 500 millibar map looked. And then a day later, the 500 millibar map changed dramatically. Instead of the 500 millibar pressure lines all moving straight west to east, they're now making massive loops north and south, all right? But understand that and understand what changed, and this would produce massive changes in the weather over the United States, and in particular where we are in Illinois, what you would do is, if you really, to understand this, and I looked at it, I really would argue you have to watch these two videos here will coincide with what you're reading in chapter 8. So where the professor here, she does a nice job of explaining to you why the westerly winds move either zonally or meridionally and what causes that. So in this example here, she's kind of showing you what zonal airflow looks like in the westerlies versus at different points she starts to give you examples of meridional airflow, like here, all right? And so I added this video here because I believe you would need the concepts you would be getting from chapter 8, and these, if you're not learning from chapter 8, these videos here will do a great job of really prepping you to understand how to complete the sections on this assignment that deal with questions 8 and 9, okay? So if I get on here again, question 8 starts right here, and I'll just give you a heads up that questions 8 and 9 are really weighted heavy for the assignment. To me, they really start to get at you understanding how the weather is predicted by changes in air pressure. So you don't want to take questions 8 and 9 very lightly. If you don't understand them, you might want to get a hold of me or ask me to do more of a demo on them. But I expect that you'll see that there's 3 or 4. There's 4 questions for question 8, and in question 9, there's 4 questions as well. This is a short answer question, and this is a short answer question. And so these 2 questions by themselves are worth 8 points out of a total 20 for the entire assignment. So I wanted to give you a heads up so you were prepared for that. So that's all I wanted to go over. I'll post this on the assignment and give the class a heads up. And that way you guys can use this, and I'll let everybody know. I'm going to put the video directly on the assignment so you guys can see it in future classes, and maybe this will help you go through the video. All right? Thank you again, and I hope this helps some of you.